there are a lot of different ways of proving geometrical theorems. And sometimes some are more useful than others. And I want to take a look at a few of them and show you how some might be more intuitive and helpful than other ones. And you can pick the ones that you like to help us build insight into how to prove theorems, which is what we're all about here. So let's start off with the theorem at hand that we want to consider. So we're given this figure, and we're also given that line L is parallel to line M. Okay, so we're given this, and we have this transversal. And what we want to do is we want to prove that angle 1, which is this angle right here, is congruent to angle 2. So I want to prove that these two angles are actually congruent. So in fact, this is sort of also known as the alternate interior angle theorem between parallel lines and a transversal. So we want to now see that really is true. Now, what we're going to have to help us in this particular one is actually a flowchart proof. So we're actually going to be given the flowchart proof, and I want us to take a look at it and understand exactly how to read this, what it means, and then let's take this flowchart proof and convert it to a usual two-column proof. Okay, so let's see what we have here. Well, see, this is where sort of the action starts. So we're given that L is parallel to M, and so that's given. And we also notice that that immediately implies that angle 1 is congruent to angle 3. So these are congruent. Now, why are they congruent? Well, because they're corresponding angles of parallel lines crossed by a transversal. So by the corresponding angles are congruent result, we know that, in fact, these two are congruent. Okay, so using the fact of the given, we see that this is true. Now, we notice, by the way, that angle 2 and angle 3 are vertical angles. So we know that vertical angles are congruent. And so, in fact, this fact right here allows us to conclude, together with this fact, that angle 1 must be congruent to angle 2. And why? Well, just by substitution. Here I know that angle 1 is congruent to angle 3. Here I know that angle 2 is congruent to angle 3. Since these are both angle 3's, therefore these two must be congruent to each other by substitution. So that's sort of a flow chart. You can see the flow of the logic of the proof. Now let's write that down in a two-column proof and see how that would look a little bit maybe more rigorously. So what I'm going to do here is actually, I'll put this here. And I'll put this here, and let's see if we can make this a go. There's a lot of stuff here. Everything is so big. You know, everything's big. In geometry, everything is big. So we'll make this work. All right, so first I'm going to start with my given. So I'm going to write here that L is parallel to M. And why is that true? Well, that's just given. In fact, I'm going to take this and put it over there. So we don't have to look at it right here, and you can see it there. So that's just the given. Okay, great. Now, what's the next thing that I want to conclude? Well, if you look over here, using the given, I see that angle 3 is congruent to angle 1. So angle 1 is congruent to angle 3. And why is that true? Well, in fact, the little flow chart tells us why. It's because these are, we know that corresponding angles are congruent. And notice that these are corresponding angles of two parallel lines cut by a transversal. Okay, what's the next thing that I want to use? Well, the next thing I want to use is the fact that we know that vertical angles are congruent. And so I see these are vertical angles. And so I see that angle 2 is congruent to angle 3. And why is that? Well, because we know that vertical angles are congruent. Great. And what's the last step? I want to put these two steps together. I see that angle 1 is congruent to 3. I see that angle 2 is congruent to 3. So therefore, angle 1 is congruent to 2 by substitution. So if we just substitute, I see that angle 1 is congruent to angle 2, and that's by substitution. And you will note that's exactly what we were asked to prove. We were trying to prove that angle 1 is congruent to angle 2. So this is a two-column proof of that flow of the argument that was given in the flowchart proof. So now you can see how to take a flowchart proof and convert it to a two-column proof. Really neat. And the flowchart allows us to see the flow of the argument. Remember that when we're trying to prove a theorem in geometry or in anything else, we need to have a logical thread that leads us through the beginning, what we're given, to the end, what we're trying to conclude.